Okay, so starting another exam paper walkthrough for you. This time it is the November 2018 paper 2, a paper that I've given out to my students this week, just to prepare them for this second exam paper up and coming on the 6th of June. So first question, multiple choices is the way with the AQA papers. Here's a rectangle, work out the perimeter. We need to know the perimeter is the one that goes all the way around the outside. So we need to calculate 7 add 5, add 7 add 5. So it's 14 and 5 and 5, 14 and 10, 24 centimetres. Next one, slightly trickier. Circle the number greater than negative 0.9. So tricky thing about this one is that because it's not only decimals but negative, it throws people. So the thing we have to remember is that with negative numbers, the bigger the number, the smaller it is. So to be greater than negative 0.9, the number part of this problem has to be smaller than 0.9 because all the numbers are negative. Now a quick check on my calculator will confirm what I kind of already know, which is that 9 over 10 as a fraction is equivalent to 0.9 as a decimal. There it is. So I can now say, well, that is also negative 0.9, always worth getting them all in the same format. So that's negative 0.9. So if we look at those numbers, which is the smallest number-wise would be 0.89. So actually, minus 0.89 is the number that is bigger than negative 0.9, because if we think about it on this number line, we've got negative 0.9 like here, and then negative 0.89 is just a teensy bit closer to 0. Okay, question 3, we've got to simplify what we've got there. The important thing to remember here is that that minus relates to that 3. It isn't saying 8x take whatever comes next. It's the minus relates to the 3, the plus relates to the 6x. So we've got 8x add 6x is 14x, and then the minus 3 does nothing other than sit around and mind its own business at the end of the problem because it hasn't got an x on it. Question 4, what is the angle of a turn from clockwise from southwest to east? So we look at our compass points there. If you want to do the never eat shredded wheat, okay, whatever it is, you need to know what the order they go in as we go around clockwise, N-E-S-W. So southwest is the point halfway between south and west, that's there. And from there, I'm turning it in a clockwise direction, so it's in the same direction as an analog clock, to east. So how far have I turned? Well, I know that each kind of quarter circle here is 90 degrees. So that's 90 degrees, and that too is 90 degrees. Then we've got this part of the turn here, the bit between west and southwest, which is kind of half of 90 degrees, which would be 45 degrees. So the total turn would be 1990, which is 180, plus 45, which is 225 degrees. Okay, question 5. Lucy works for 37 hours a week. She receives a weekly wage of £303.40. Her pay is increased by 25 pence per hour. What is her new weekly wage? So one way to do this is to say, well, what is 37 lots of 25p? Because she's going to get that much extra on her wage. So let's see, every 4 would be £1. So 4 times table 28, 32, 36. 9 times, so there's going to be 9 whole pounds for 36 of those, and then 1 additional 25p. You can, of course, do that on the calculator. I just don't want to faff around messing with the screen. So once I know I'm getting £9.25 extra, £303.40 plus, well, £303 plus £9 is £312, and then the 40p plus the 25 is 65p. So her new pay rate would be £312.65. Question 6a. So question 6a is a bank statement question. The important thing about these bank statement questions that they seem to be keen to throw into exam papers is knowing that debits are money that is taken away, things that you pay for. Credits are money that's added in. So here, we've got £1,140.79, and then we need to take that £256 to get the new balance, which is £884.79. So we then have another bill. We have a gas bill to pay. So from the 88479, I need to take away a further £87.31, which is 797.48. So £797.48. Finally, we've got a credit. We're getting paid our salary, so that money goes into our account. So I add that on. £2,069.75. So that's 2,867.23. So here where it says, what is the meaning of debit as used in the bank statement, we would say money that is taken out. Or spent. Right, question 7. The line AB is shown on the grid. A is 0, 2. B is the point 65. What is the coordinates of the midpoint of the line? So, trick to doing these usually is to look kind of horizontally. How far do we go? That's 1, 2, 3, 4, 5, 6 across. So halfway would be 3. Vertically, how far do we go? That's 3 up. So half of 3 would be 1.5. So we're going to go up to there. The midpoint is going to be there. So the midpoint of that line is going to be 3 and then 3.5. Absolutely fine to have a coordinate in your decimal in your coordinate. Okay, 7b. C is another point on AB. C is closer to B than A. The coordinates of C are whole numbers. Work out the coordinates of C. So I thought the thing which is hardest to interpret there is that C is another point on AB. Which basically means it's somewhere on the line. So this point is somewhere on the line. It's closer to B than A, which means it has to be on this side of the midpoint. Whoop. And finally, it has to have whole number coordinates. So whole number coordinates would mean that it has to lie exactly on a coordinate. So on an exact crossing of those lines on the grid. So this side needs to be just there. So the point C must be 4, 4. On the line, nearer to B than A, and on an exact coordinate. Okay, question 7c. On the grid, draw a line from the point 0, 0 that is parallel to AB and 2/3 as long. So from 0, 0 going parallel to AB would basically mean it has to go in the same direction. So if we use that kind of 6 across 3 up idea again, that tells us that if it's going to run parallel, it needs to be running in that direction like that. Now if it's also going to be 2/3 as long as AB, that means I need to make it shorter somehow. So I've drawn the dotted line to guide the direction. I'm now going to kind of solidly draw in how long it needs to be. So if I look at the line AB and split it into 3 equal pieces, the good thing is that those 3 pieces seem to be 1, 2, 3 landing on the exact coordinates. So if I just go through 2 exact coordinates, like that, that is the line I need to draw. So there it is. Right, question 8. Lena is at the gym. She will use 3 pieces of equipment. She will use each of these pieces of equipment once. She will use the row machine first. What is the possible orders that she could use the 4 pieces of equipment? So when doing this, we're doing a systematic listing problem. So we're saying R has to come first. So then she could use S, T, B. So going kind of left to right, line by line. Then what I like to do is think, right, let's stick with R and S first and just switch those last 2 around. So she does B before T. Now I know that there's no other ways that she can do R then S, and then B, then T in a different order, because I've kept R and S the same. So now I'm going to move T to being my second activity, then do S, B. And again, I'm going to stick with RT at the beginning and just switch those last two. And finally, I need to put R, then B at the beginning. And then think, right, so I've got S, T, T, S. We've ended up with 6 different combinations, which makes sense because she's got 3 choices where to go first. Then for each of those 3 choices, she ends up with 2 choices of where to go second, and then she has to use whichever one she hasn't used. So there's 3 times 2, 6 choices. Question 8b. Table shows how long Lena spends on each piece of equipment. Lena starts rowing the machine at 1:50, has a break of 4 minutes between each piece of equipment. What time does she finish? So watching most students work on this in lesson, what they seem to do is say, right, 1:50, let's go 15 minutes later. That is 2:05. And then another 4 minutes later, that's 2:09. So then, now she does the stepper, so she starts at 2:09. She spends 13 minutes on the stepper, so that's 2:22. She then has a 4-minute break, that's 2:26. So then she goes on the treadmill at 2:26. She spends 35 minutes on the treadmill. So that's 61, so that's gone past the hour, 3:01, and then another 4-minute break is 3:05. So she goes onto the bike at 3:05, spends 1 hour and 35 minutes, or 1 hour 30 minutes, sorry. So that's 4:35 that she finishes on the bike. And that was what they wanted to know. When was it that she finished her exercise routine? What time did she finish on the last piece of equipment? So there's no need for another 4-minute break. She finishes at 4:35. Okay, question 9. Table shows the number of messages Sam received each day for 5 days. Sam draws a composite bar chart to represent the days. So if we have a look at that, we can see that what's happening is we've got a dark bar representing the 12 emails, then we've got a light bar going up by 5, okay, to represent the texts, leading to a total of 17, which is how high the bar is altogether. No need to write these down, but since the calculation is quite quick in my head. So we have got Tuesday was 8 emails, so we're looking for a bar 8 tall there, which will leave solid, and then we have got a bar 6 tall taking us to 14, which represents the texts. Then we've got Wednesday, we need a bar which is 10 units tall to represent the emails. And we need a bar 3 units tall on top of that, taking us to 13 to represent the texts. Thursday, we need a bar which is 6 tall on the bottom to represent the emails, and another 6 tall on top, taking us to 12 to represent those texts. And finally, we have Friday, where the emails are thick and fast. There is 12 emails coming in, so we need a bar 12 tall for the emails, we need to shade in, and then we have a bar which is 4 tall, taking us to 16 to represent those texts. Okay, question B. In total, what fraction of the messages were emails? Give your answer in the simplest form. So to do this, we need to say how many messages there were altogether, how many emails there were. So 12 and 8 is 20, plus 10 is 30, plus 6 is 36, plus 12 is 46, 48. 36, 46, 48, yeah. And then total number of emails, we've got 30, 44, 56, 60, 72. So we have the fraction 48 out of 72. Now, we could simplify that using our brains, but this is a calculator paper. We can be lazy about it if we wish, just like we could have used a calculator to add up those numbers if we'd have wanted to. So let's go with that. 48 out of 72 on my calculator, 2/3. There's my simplest form. Right, question 10. Each side of a square is made 3 times as long. What happens to the perimeter? Now, if you're not sure about this, just start with a square. Probably the simplest one we could start with is 1, 1, 1, 1. And we can see that the perimeter of that square is 4. Make the sides all 3 times longer. It doesn't have to be to scale, but let's have a look. So the perimeter here is 12. How many times bigger has it got? Well, 4 times 3 makes 12. It's getting 3 times bigger. Now, it doesn't, obviously can't matter what size of square we start with, because if it did, they'd have had to tell us. So just for completions and to show you it doesn't matter, if we've got 2, 2, 2, 2, we've got a perimeter that's equal to 8. That would give us 6, 6, 6, 6 going around the outside here when we made it 3 times bigger. That's a perimeter of 24. What do I times 8 by to make 24? It's still 3. So 3 times bigger. Question 11. Here's a list of ingredients to make 6 pancakes. Complete the list of ingredients to make 9 pancakes. Now, most students I taught seem to find no trouble in this. They realise that if I've got 6, I need an extra 3. That's an extra kind of 50% on all these numbers. So they go half of 120, that's 60, and add it on is 180 grams. Half of 2, that's 1, add it on, that's 3 eggs. Half of 210, that's 105, add that on, that's 315 millilitres. Question 11b. Convert 210 millilitres to fluid ounces. Now, 1 fluid ounce is equivalent to 28.4 millilitres. So I need to know, in my 210 millilitres, if we bear in mind that the number of fluid ounces should be smaller than the number of millilitres, how many lots of 28.4 are in there? So I need to divide the 210 by 28.4, then I get that. It asks me for the answer to 1 decimal place, so I hit the SD button. I've got 7.3943 da da da. So rounding 7.3943 etc. to 1 decimal place. I look at the 3, look at the next number, it's a 9, so the 3 goes up. That would be 7.4. Would be good to write the 7.39 and so on down, just to show that you've made the correct calculation. Okay, question 12. Reflect the shape A in the x-axis. So the x is a cross. It's labelled for a start. So I need to reflect that down. So quite a nice reflection. 1 square down, 1 square beyond, that corner goes there. 1 square down, 1 square beyond, that corner goes there. This corner, 1, 2, 3, 4 down, 1, 2, 3, 4 beyond, it goes there. Okay, question 13. A charity sent an appeal letter to 3,000 people. The letter asked for a donation of money. Here is some information about the last appeal the charity sent out. Half of the people who sent the letter made a donation. The average donation was £8.60. 1/3 of the people who made a donation filled in a tax form. The government adds 25% to the donations of these people. Using this information, work out the amount the charity can expect to receive from the appeal. So if we kind of assume that all of these things remain constant, then we can expect 1,500 people to make a donation. Now, on average, they're making an £8.60 donation, but 1/3 of them will also fill in the tax form and get an extra 25%. So if we divide this up into 3, we've got 500, 500, 500. So 1/3 of them will do the tax form. So 1,000 didn't do the tax form. So these people donated £8.60. These people also donate £8.60, but an extra 25% as well. So if I grab my calculator, I need to add 25% onto £8.60. So I get 8.60. I could divide that by 4, then add it on, or I can use the decimal multiplier shortcut. 1.25 will add 25%. Tells me that they are donating £10.75. So I've got 1,000 donations of £8.60. That will be 8600 times in £8.60 by 1,000, so that's 8,600. And I've got 500 donations of £10.75. I think I will go to the calculator for that one. So £10.75 multiplied by 500 of the donations. We've got £5,375 from them. So putting those together, we've got £13,975. That's my final answer. Right, question 13 part B says the average donation from people who filled in a tax form was more than £8.60. How does this affect your answer to part A? Well, that would mean that the extra 25% would be going on a higher average, and therefore we would be expecting more money to come in. So more money being boosted, as it were. So we'd be seeing a higher amount of money being given that 25% boost. Okay, question 14. Lee wants to draw the graph of y equals x for values of x from -5 to 5. Here is his graph. Make 2 different criticisms of the graph. Well, looking at it immediately, I would say that the issue we've got here is, first of all, the line y equals x should be a perfect diagonal line going through 0, 0 like that. So -1 on the x-axis should be at -1 on the y, and so on and so forth. And so we should be getting a line like that. So you could say, first of all, that with his plot negative x values at positive y values, or something like that. So that's incorrect. He's plotted the negative x values incorrectly. And secondly, and I'm looking at this now and I'm thinking, what on earth is wrong with it? Apart from the fact that it's obviously a V shape and it should be a line, what's the problem? And the only thing I can really pick up on is, if I look at this, he says he wants to go from -5 to 5. We look at the image, the graph is going from -4 to 4. So I would suggest that would be our second criticism. So values of x from -4 to 4. And not -5 to 5. Alright, question 15. A company uses this formula to work out the cost £8 of a taxi ride. £4 is a fixed charge, N is the number of miles that are travelled, B is the charge for booking online. Claire books a taxi online and travels 8 miles. Altogether she pays £20. How much is the charge for booking online? So if you think about that formula, we know that the amount she's paid is £20. That has been calculated by doing 4, plus 1.8 times the number of miles. So if we pull a calculator up, do 1.8 multiplied by the number of miles she's gone, which is 8, we can see that that is 72 over 5, which is £14.40 or 14.4. And then the last thing which is charged is that online booking fee that they haven't told us. So at the moment, the charge we've got is £18.40, and we know that the total charge was £20. So whatever's missing to make £20, the £1.60, was the booking fee. Okay, 15B, a different company has a fixed charge of £3, charges £1.90 per mile, has no booking online fee. What is the formula for the cost £C of a taxi ride with this company? So this company, their cost £C is made up of the fixed £3 charge plus a charge of £1.90 per mile. Okay, you could also have 1.9M, there is no need to put £1.90 or 1.90. So there we go, £3 booking fixed charge plus £1.90 per mile. Okay, question 16, what does A and B represent in the probability of A and B? It is A and B together, that is what is called the intersection. Okay, A or B or both would look like that. A but not B, and then not A and not B, right. Question 17. The circle has a circumference C and a diameter D. C is KD. What's the value of the constant K represent? The answer is pi. Because the circumference is pi times diameter. So if C is K times D, that K would be pi. How many diameters make the circumference? Question 18. There are 240 cows on a farm. On the farm, the number of bulls to the number of cows is 1 to 30. How many bulls are there? So that 240 cows is representing the 30 in the ratio. 30 times 8 makes 240. So 1 times 8 would mean we need 8 bulls to go with our 240 cows. 18 part B. Assume that 240 cows produce milk for 10 months each year. Each cow produces 25 litres of milk per day. Estimate the total milk production in litres of the 240 cows in 1 year. You must show your working. So 25 litres per day. The problem we've got here, of course, is we don't know how many days in a month. So we could go kind of 28 days and just assume all months of February, which we could, or we could say, well, let's just say it's 30 days in a month on average. So 25 litres of milk per day times 30 days in a month times 10 months of the year is 25 times 30 times 10. So let's stick that in. 25 times 30 times 10. I could totally do that in my head. 7,500 litres. Probably want some communication. So 25 litres per day. 30 approximate days in a month. And then 10 months. Okay, question 19 here is a right-angled triangle. Show that x is equal to 12. So this is Pythagoras' theorem, isn't it? So we've got a squared plus b squared equals c squared. If I want to work out the longer side of a right-angled triangle, I square, I add, I root. Grab a calculator, stick that in, make sure it looks just like that. So the root goes in first. 7.2, hit the square button, plus 9.6, hit the square button, there it is, boom. So we've got an answer of 12. So it works, happy days. Question 20, work out the values of A and B in the identity 5 bracket 7x plus 8 plus 3 brackets 2x plus b is 3 equals bar thing ax plus 30. So Identity means that these things are equivalent to each other. They're always the same, and we represent those with a 3-bar equal sign. So whatever the values of A and B and X are, these two things are always the same. So if we imagine just simplifying on the right-hand side, we do 5 times 7x is 35x, plus 5 times 8, which is 40. We'd say then plus 3 times 2x, which is 6x, and then we'd put 3 times whatever else is, which is b. Now that has to give us 8x plus 13. So there's still some simplifying to do on this right-hand side, because we can see that when we put the x's together, we get 41x, and then we've got the 40 and the 3b left over. So because we've got 41x here, and that's got to be the same as a times x here, we've now established that the x has to be 41. So the next part is possibly more confusing, because I'm looking at what numbers are going to be involved, and it doesn't look particularly nice. We can see that this bit, the 40 plus the 3b, has to give us the 13. So whatever the 3b is, it's what we have to do to 40, but we have to add on to 40 to make 13. Well, for starters, we need to take off from 40 to get to 13. The amount that we need to take away from 40 to get to 13, well, if we take 7 away, we're at 33, and then another, so the 3b, another 20. So that 3b, the add 3b, is actually taking 27. That's what it's doing. So b must be minus 27 divided by positive 3, which is negative 9. Again, you get stuck. Calculator is there for that calculation. Not a nice question, that. Not nice at all. Properly taking the challenge level up to 12T for a foundation paper there. Okay, question 21, a bit more friendly. The first 4 terms of a linear sequence are, circle the expression for the nth term. So a couple of options here. We can just figure out what the first 4 terms are by putting n equals 1, 2, 3, and 4 and seeing what they give us. So 1 plus 6 is 7, 2 plus 6 is 8, 3 plus 6 is 9. That's not right, so it's not that one. 4 times 1 is 4, plus 3 is 7. 4 times 2 is 8, plus 3 is 11. 4 times 3 is 12, plus 3 is 15. 4 times 4 is 16, plus 3 is 19. That one matches, so this one is correct. Just to confirm the others are wrong, 7 times 1 is 7, plus 4 is 11. That's not even the right first number. And then 1 plus 4 would be 5. Again, not even the right first number, so that one's wrong. Or we could have done it by calculation, if you've done this before. You start with the sequence 7, 11, 15, 19. We say, right, we've got a sequence here which is going up in 4s. That means that this sequence is somehow linked to the 4 times table, because the 4 times table is a series of numbers that goes up in 4s. The problem being, of course, that this sequence is a slightly different size. They've been made a little bit bigger or a little bit smaller. So our 4 times table goes 4, 8, 12, 16, and that has the rule 4n, because 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and so on. So what do we have to do to our 4n to get this series of numbers? Well, we've seen it in the answer and we can see it here now. What do I do to the 4 times table to get the 7, the 11, the 15, the 19? I have to add 3 on. Each of these numbers, if I add 3 on, gives me that one. So I need to add 3 onto the 4n to get the final rule. Okay, question 22. Here is some information about 20 trains leaving a station. A, work out an estimate for the mean number of minutes late. So, we have to work out some midpoints. So 0 to 5 will have the midpoint 2.5. Now we use that as an approximation of how late these 12 trains were. 5 to 10 will have the midpoint 7.5. 10 to 15, 12.5. Now anything bigger than 15 how do I work out a midpoint for that? Well, actually it doesn't matter because there's no data there. Look, it says there was 0 trains. So in actuality, I've just got 3 rows there. So then, what I do, this is effectively my X, my piece of data, or T in this case. And I need a frequency column, which is this, how many things were in that group. So then I need an FX column, frequency times midpoint. So I do 12 times 2.5. That's 30. That goes in there. So what we're saying here is, if we assume that all 12 of these trains were 2.5 minutes late, and we say, right, so we first 12 numbers in our list of data, because we're working out the mean, are all 2.5. If I add up 12 2.5s, the total of those 2.5s is 30 just here. Then I say, right, let's now assume that the next 7 trains are all 7.5 minutes late. So I've got 7 lots of 7.5 to add up as well. So because we've got lots of the same number, we can just use multiplication to add them up quickly. 52.5. Finally, I've got 1 train that we're assuming was 12.5 minutes late. So to work out an estimate for the mean, we have to add them all up. So we've already added them up in groups. The 12 which we're saying were 2.5 minutes late, the 7 we were saying was 7.5 minutes late, and the 1 which we've said was 12.5 minutes late. So we're going to add those up now. So let's see, that's 50, 64, 65, 70, 80, 95. So what we do is we add up that FX column to get 95. We then divide that by how many trains there were, and we're told in the question that that was 20. We can also figure that out by adding up this column here. 12 add 7 add 1 would be 20. So 95 divided by 20, being lazy again, doing that on the calculator, 95 divided by 20 is 4.75. And that is our average number of minutes late, 4.75. Does that make sense in the question? Well, it's definitely between 0 and 15 minutes late. It is in this lower group, but since the vast majority, 12 trains, were in this lowest group, least minutes late, I think that seems a pretty good estimate. Now, the station manager decides to look at the information in more detail. So he works out an estimate of the mean using this information. How will this estimate compare with the answer to part A? So what's our midpoints going to be? We've got a midpoint of 1 here, 3 here, 5 here, 7 there, 9 there, and 11 there. So if we look at what our midpoint times by our frequency would be here, we'd end up with 12, 35, and 11. Putting those together, we get 58 as our total. Now that's a lot smaller than 95, so we would suggest that this is going to be lower than it was in part A. Mostly because I guess the midpoints have actually all got lower, haven't they? The midpoints that were multiplying by 12, 7 and 1 are all smaller in this question, in this second part, than they were in the first part. Okay, question 23. The 2 identical quarter circles are cut from a rectangle as shown. Work out the shaded area. Interesting. So to work out this shaded area, I'm going to need to work out what is the area of the whole rectangle. That's what my brain is telling me. And I'm also going to need to work out what the area was of the kind of 2 quarter circle bits there. So how big are they? So if I want to work out the rectangle, I need the length and the width. So how wide is this rectangle? Well, if we think that because these are, we're told, identical quarter circles, we know that this length and this length are both the radius of the circle. And so this length and this length. So effectively, by showing us this diagram with the circles drawn, they're telling me that the rectangle is half as wide as it is tall. So we know that the radius of the circle, the width of the rectangle is 6 centimetres. So to work out the area of my rectangle, I do 12 times 6. Rectangle area is 72 centimetres squared. Now, to work out the 2 quarter circles, let's think of them, instead of being 2 quarter circles, let's put them together into 1/2 a circle, which is got a radius of 6. So the area of a full circle is pi times r squared. Because this is a half a circle, we'll need to divide it by 2. Grab my calculator, let's calculate that. So we need to do, press the shift button and the 10 to the x button to get the pi, times 6 squared, press my equals key, there we go, 36 pi, and then I need to half that, so that's 18 pi. I could write that as 18 pi, but it doesn't indicate that they want me to give the answer in terms of pi. Guess they probably won't complain if I did, but there we go. So let's call that 56.5. So the area of our shaded region is 72 minus 18 pi, or 72 minus 56.5, which I can then calculate on here. So 72 minus the last answer, 15.5 centimetres squared. So work out the area of the rectangle, work out the area of the 2 quarter circles, take the quarter circles away from the rectangle, whatever's left is your shaded area. Question 24. We're getting to very weird now. The diagram shows the position of a tap when off and fully on. The tap is fully on when the angle of turn is 180 degrees. Basically, you yank it round all the way to 180 degrees, it's fully on. When the tap is fully on, the water flows out of the tap at 14 litres per minute. The rate at which the tap flows out is in direct proportion to the angle of turn. So in other words, whatever fraction of 180 we've turned it by, that's what fraction of 14 litres comes out every minute. So, the water flows into a tank with a capacity, a very specific capacity of 79.8 litres. Will it take less than 7.5 minutes to fill the tank? So, how much water's coming out? So we need to work out 135 180ths of 14. That's got to be our first task. So we can do that the long way or the quick way on the calculator. So we could start with 14, divide it down by 180. That's 1/180th of 14. Then times that up by 135. And we can see that we're getting 21/2, 10.5 litres per minute. Okay. The quick way that I mentioned is to use multiplication. Just say it's 135 over 135 over 180, and just multiply that by 14. It'll give us the same answer, look, 10.5 litres per minute. So if it's doing 10.5 litres every minute, if we times that by the 7.5 minutes by 7.5, that tells us that we'll fill 78.75. So 10.5 times 7.5 minutes, 78.75 litres. Will it take less than 7.5 minutes? It needs to get to 79.8 in 7.5 minutes. No, slightly longer. So what I've done there, said 10.5 litres every minute, times that by 7.5 minutes, suggests we could get 78.75 litres into this tank in 7.5 minutes. So you want to get that done, maybe turn it fully on. Then it'll go at 14 litres a minute, loads easier. Right, question 25. This triangle is equilateral. It's got loads of algebra on the sides. Is the perimeter of the triangle greater than 1 metre? So the sides are currently given in centimetres, but also in algebra. Lovely. So what we need to do is establish what the value of x is, because that will allow me to establish how long the sides are in centimetres. I can then determine whether there's more than 100 centimetres all the way around, which will let me work out the perimeter of the triangle. So in order to do this, I need to work out what x is. Well, how do I work out what x is? Well, I know that because this is equilateral, all three of these sides are the same length. That tells me that whatever the 6x minus 10 is, has to be worth the same as the 4x plus 5. So what we've got here is we've got an equation with an unknown on both sides. I've chosen to do the 6x minus 10 equal to the 4x plus 5 rather than the one on the bottom, because the one on the bottom has a bracket in it, which means it takes more work. So looking at these two, if I got a balancing equation here, I need to get rid of the x's on one side. So I always go for work out what the biggest amount of x's is, which is the 6x, and remove them from the other side. So 4x I'm taking off this side to leave me with just the plus 5. And then 4x I'm taking off this side to leave me with 2x, and the minus 10, just like the plus 5, doesn't change. So now that I've got the x's on one side of the equation, the next thing I need to do is get rid of the number that's next to them. So we're going to lose that. First I got rid of the 4x by taking 4x, so next I'm going to get rid of the number from the x side by adding plus 10 onto both sides, because if I add 10, that undoes minus 10. Leaves me with 2x, but then I've got to balance that by adding 10 over here onto the 5, which is 15. Note that when I took x's, I only changed the terms with the x's in, and when I'm messing with numbers, I only change the terms which are the numbers. So if 2x is equal to 15, that means I need to halve to work out what 1x is, and we've got that 1x is 7.5. So they've made this kind of sneaky in terms of giving us a weird number for x. So now that we know that x is 7.5, we can go back into here with 7.5 to work out how long that side actually is. So we'll do 6 times by 7.5 is 45, take away 10 is 35. So that tells me that according to my x value, this is 35 centimetres. I am going to substitute the 7.5 into all the others as well, because I want to make sure that they all give me 35. If they all give me 35, then I've found the right value for x. If I'm not getting 35, then there's something wrong. So this one, I do 4 times the 7.5, that's 30, add the 5, is 35. Things are looking good, because those two should definitely give me the same one. And now, finally, I need to get 10 times x minus 4, so 10 bracket 7.5 minus 4, close bracket, is also 35 centimetres. So now knowing that all the sides are 35 centimetres, I'd say, right, 35 add 35 is 70, 70 add 35 is 105, so it's 105 centimetres all the way around. And then, important reason to go back and read those questions again. I've done all the hard work. I've set up my equation, I've worked out what x is, I've worked out that all the sides are 35, I've added them all up, worked out that it's more than a metre. I need that conclusion. Yes, it is greater than a metre. Make sure you've got that final statement. If it's asked the question, you've actually answered the question that's in the paper. You've shown it, but have you answered it? Okay, yes, it is greater than 1 metre. Okay, question 26 and 27, final questions on the paper. An approximation for the value of pi is given by 4 bracket, okay. Use your calculator to show that this approximation is within 0.1 of 3.14. Okay, so I suppose what I've got to do is get my calculator. I need to type that in. So 4 bracket 1 minus, give me a fraction, 22 over 57. And the next bit, add, give me a fraction, 22 over 85. And next, give me a minus. Then it's another fraction, 22 over 105. We come to the end and we plus, and we need a fraction, 22 over 117. Make sure I got my 22. And then finally we've got a minus again, and that's 22 over 242. Let's just make sure we've got that one. We'll know if we've got it right, because when I press equals it should be almost pi. So show that that is within one thing. So we'd say 3.0418 and so on. Might as well write it down, 0418 39619. And then if we add 0.1, we get 3.1418399619, which is, yeah, so less than 0.1, so less than 0.1 from 3.14. I suppose the other way to do it is to say 3.14 minus 3.04 and so on equals, and show that the answer is less than 0.1. So 3.14 minus my last answer is 0.098. And that 0.09816 is obviously smaller than 0.1. Right, question 7, work that out, give answer in standard form. Well, let's be lazy about it. Let's just grab a calculator. There we go. Type it in, 9.12. Some people like this button, some people don't. Times 10 to the power of 10. 3.2 times 10 to the power of 4. So all you do, you press that times 10, and then you just type in the power, and it understands that that's what you want the power on the 10 to be. So it interprets those numbers as standard form. We press equals, and we can see we've got 2, 8, 5 and 4 zeros. Writing that down, because if it's a 2-mark question, I've probably just got one of them. Right, when we write a number in standard form, we need to put the decimal point into it, so that it's a number between 1 and 10, so it's 2.85. Then we need to figure out how many times do I need to multiply that number by 10 to get the original number. So I need to multiply it by 10 6 times. So 2.85 times by 10 to the power of 6. Now, ladies and gentlemen, it's the end of the paper.